Dear students, hope you are great. Today we are going to continue to answer chapter 3, section 1. Let's start. Question number 8. Nitrogen forms several compounds with oxygen. Measurement of masses of nitrogen and oxygen that form upon decomposing these compounds indicate that one compound contains 2.28 grams of oxygen for every 1 gram of nitrogen, while the other compound contains 0.570 gram oxygen for every 1 gram of nitrogen. Calculate the simplest whole number ratio. So, in this problem, we need to calculate what? The ratio. Simplest whole number ratio. We use law of multiple proportion. Look, there is the answer. We have two compounds, compound 1 and compound 2. Nitrogen in the compound 1, nitrogen of the compound 1, the mass of nitrogen in compound 1 will be 1 gram, and the oxygen indicate that one compound contains 2.28 gram of oxygen, and the mass of oxygen in compound 1 2.28 gram, while in the second compound contain 1 gram of nitrogen and 0.570 gram of oxygen. And we want to calculate what? To calculate the whole number of ratio. The whole number of ratio. In nitrogen, the ratio of nitrogen in the compound 1 and 2 and compound 2 will be 1 to 1, as here 1 gram, and in first compound, the second, and also in second compound, the nitrogen 1. So the ratio of nitrogen 1 to 1. So what about oxygen? Oxygen in compound 1 contains 2.28 gram, and in compound 2 0.570 gram. And we want to calculate the ratio of oxygen in the two compounds. So we should to get the ratio of of oxygen in the two compounds, we should to divide the two compounds, the oxygen of the two compounds, by the smallest number. So here in oxygen, which one is the smallest number? Oxygen in compound 1 or oxygen in compound 2? Oxygen in compound 2. So here in compound 1 we should to divide by 0. Divide by 0.570, and in compound 2 divided by 0.570. So the answer will be 4 to 1. Here in the first compound the answer will be 4, and in the second compound 0.570 divided 0.570 will be 1. So the ratio will be 4 to 1. Question number 9. Sulfur forms several compounds with fluorine. Upon decomposing, one sample produces 4.45 gram of fluorine. So we have two compounds, compound 1 and compound 2. In compound 1 contains sulfur and fluorine, and also in compound 2 sulfur and fluorine. Sulfur in compound 1, fluorine in compound 1 4.45, and 1.25 gram of sulfur, and the other compound produce 4.43 of sulfur of fluorine and 1.87. And want to calculate the simplest whole number ratio in the two compounds. In fluorine the ratio will be 1 to 1, as 4.45 divided by 4.43 will be 1, and also 4.43 divided by 4.43 will be 1. So the ratio of fluorine 1 to 1. What about sulfur? Here, which one is the smallest number, 1.25 or 1.87? 1.25. So in the first compound we should divide by, here in the first, divided by 1.25, and in second compound divided by 1.25. So the answer will be here in the first compound, 1.25 divided 1.25 will be 1, and here in second compound 1.87 divided 1.25 equal 1.5. So the ratio of sulfur in the two compounds will be 1 to 1.5. Number 10. A sample of nitric oxide was found to have 14 grams of nitrogen and 16 grams of oxygen. So here we have compounds called nitrogen oxide. Nitrogen oxide contain nitrogen and oxygen. Nitrogen in nitric oxide 14 grams, while in oxygen 16 grams. Sample of nitrogen dioxide was found to have, we have also another sample, another compound, nitrogen dioxide, NO2. We have 14 grams of nitrogen, 14 grams of nitrogen. Here we want to calculate what is the expected amount of oxygen. We want to calculate the oxygen amount of oxygen in nitrogen dioxide. Here we have two different compounds contain the same element, nitrogen and oxygen. The ratio of nitrogen in the two compounds will be 1 to 1. We have here 1 nitrogen and 1 oxygen, so the ratio 1 to 1. What about oxygen? In oxygen, in the first compound 1, and in second compound nitrogen dioxide we have how many oxygen? 2 oxygen. So the ratio of oxygen in the two compounds 1 to 2. 1 to 2. When the oxygen in the first compound 1, the mass of oxygen 16. So what about 2 in second compound when the oxygen is 2 oxygen? So the answer will be 16 times 2. The answer will be 32, as we multiply 16 by 2 to get the oxygen in the mass of oxygen in the second compound in nitrogen dioxide, as we have 2 oxygen, not 1 oxygen. Again, so oxygen in first compound 1 and in second compound 2. When oxygen in first compound 1 and 2, when oxygen in first compound, the mass of oxygen will be 16. What about second compound? So here we should do cross multiplication. We multiply 16 by 2 to get the mass of oxygen in second compound. So the answer will be 16 times 2 equal 32. 10 form 2 compound with chlorine, SnCl2, Sn which is 10, and CnCl4. So we have here 2 compounds. When combined of the same mass of 10, what would be the ratio of the weight of chlorine in the 2 compounds? Here we want to calculate the ratio of chlorine in 2 compounds. In the first compound we have 2 chlorine, and second we have 4. So the ratio here will be 2 to 4 or 1 to 2 when I divided 2 by 2 and divided 4 by 2. So the answer will be 1 to, the ratio will be 1 to 2. Right? In the compound 1, in first compound SnCl2, we have the mass of chlorine 0.597, compound with 1 gram of 10, and in second compound how many gram of chlorine. We want to calculate how many gram of chlorine. So in the first compound, when the ratio of chlorine 1 to 2, 1 to 2. In the first and second compound, the ratio of chlorine 1 to 2. In the first compound, the mass of chlorine 0.597. So what about in second compound? The mass of chlorine in second compound, cross multiplication, 0.597 times 2. That's it. Problem number 12. Carbon formed two compounds with oxygen, carbon monoxide and carbon dioxide. So here we have two compounds, carbon monoxide and carbon dioxide. When combined of the same mass of carbon, what would be the ratio of the weight of oxygen in two compounds? What is the ratio of the compounds of oxygen in the two compounds? Here in carbon monoxide we have one oxygen, and in second one we have two oxygen. So the ratio 1 to 2. Ratio of oxygen in the two compounds 1 to 2. In the compound carbon monoxide, we have 10 gram of oxygen. We have carbon and oxygen, 10 gram of oxygen. And 1 gram of carbon. In carbon dioxide, how many gram of oxygen? We want to calculate the gram of oxygen. If carbon 1, so we want to calculate the oxygen. So here we should to multiply 10 by 2, as we have multiply 10 by 2, as here we have 2 oxygen in carbon dioxide at the ratio 1 to 2. So here the answer will be 20. As in carbon monoxide we have 1 oxygen and mass of oxygen 10, and in carbon dioxide we have 2 oxygen, so cross multiplication, 10 times 2 divided 1. So the answer will be 20. Last one, number 13. Here we have the following equation. Show that two molecules made of 4 atoms of hydrogen and 1 molecule made of 2 atoms of oxygen produce 2 molecules of water. So the reactant, this is the reactant and this product. The total mass of product is equal to the sum of the mass of each of the reactants, hydrogen and oxygen. What parts of Dalton atomic theory are illustrated by this reaction? What law does this reaction illustrate? Which law? When reactant equal product, which law? Law of conservation of mass, or law multiple proportion, or law of definite proportion? Which law that state that mass neither created nor destroyed during a chemical reaction? Mass of the reactant equal the mass of product. Which law? Law of conservation of mass. So this illustrates law of conservation of mass. That's it. Thanks for watching.